Hi everyone, good afternoon. Please say good afternoon. Thank you. So I don't want to keep it, a one-way traffic. I want to keep this 30 minutes very interactive. And I promise if you will be interactive, this 30 minutes will be worth the time that you will be spending here. Okay. So my topic for today is under the hood, hacking Python data types for fun and power. So let's see what fun and power we can have with the data types. A little bit about me. My name is Vivek. I am a software architect at EPAM Systems. I have around 13 plus years of experience working in Python backend and other open source tech. And I'm a learner. So today also I'm here standing in front of you to learn something from all of you and also share some of my knowledge with you. Okay. So I have some questions before we start. How many of you are using Python for more than 3 years? Nice. More than 5 years? 10 years? Good. So we have a lot of very senior experienced guys. I'm sure you might be knowing Dunder methods by now because the previous speaker has talked a lot about it. But anyone who was not aware of Dunder method before the previous talk? Okay, everyone is aware of it, nice. How many of you can explain how a dictionary works internally? Though it's not my topic for today, but I just want to know if any one of you have cared to explore and go beyond, in deeper. Can anyone explain? Just, I'll not ask to explain, just show the hands. Okay, no one. How many of you just, copy paste errors in Gen AI like Gemini, GPT, wherever, Claude or whatever you are using without reading the error? lot of guys, good. Not good, but okay. Okay, how many of you know what is Zen of Python? Very few hands. Zen of Python? Okay. For some reason, I don't know why, but I am in love with that Zen of Python. These are 19 statements written by Tim Peters, who is also the co-inventor or co-creator of Python. This Zen of Python or this 19 statements basically define the philosophy of how we write code in Python. I can talk more about it, but just go to any Python terminal and type import this and enter. It will give you all those 19 statements. Just read it, understand it. Otherwise, we can discuss it later, no issues. Or Google Pep20, same thing. Okay. So I'll not spend much time on this slide because we know data types, int, float, boolean, list, tuple, all these, right? We have classification like iterable, non-iterable, ordered, unordered, mutable, immutable, so many different types of classification we have. Then we have collections like list, tuple, dictionary set. We have collections module where we have name tuple, ordered dict, and frozen set. All these are there. And custom data types are basically our own classes or any class that we derive from inbuilt data type, and then we customize any behavior that is custom data type. Okay, now moving on. We have all heard this line, everything is object in Python. Has anyone who has not heard this line? Everyone has heard it, right? Okay. What does it really mean? What does it mean everything is object? So is everything object in Python, really, or is it? Okay, so let me break it down. We know that everything is correct. Yes, everything is object in Python, absolutely true. But object also comes from another meta class which is called as type. And type comes from something called a C struct, which is from C Python. So eventually everything is coming from that C struct, correct? So in Python, yes, it is an object, but if we go maybe 2 levels down, it's a C struct. And that's a basic C struct that we see. And if you see there, we have few things like size, type could be like integer, float, whatever, and object size, there are a few more. So it depends on which C struct we are looking at, but these are some basic types that are there in the C structs. Okay, now moving on, now how it works. So in earlier talk also we saw, right, when we call any particular method or when we call any operation, behind the scene it calls a Dunder method, okay. Now let's see that Dunder method. Okay, I don't know if my code is visible. I hope it is visible. So this is the inbuilt enter method of this len function. And if you see here, it is just saying pass. There is no code there. Then how is it working? Can anyone guess? Sorry? Correct. So behind the scene, but it must be running something, right? This is just a signature, but what is running behind the scene? C Python. And when we actually do this call, len, of course len gets called, but it is actually reading that from the C struct, the size value from there. And similarly, just like all other methods, so len is just one of the methods that I took here as an example. But if we look at, let's say, any other method, say add, again signature with just pass. So all built-in types are having empty signatures, and their implementation is there in the C struct. Oh, sorry, not in C struct, in C Python. One of the Zen, practicality beats purity. So C Python or C struct is the purest form, but it's not practical. We cannot, go to C struct and write code in C. So what's practical? Practical is dunder methods. That's where practicality beats purity. This, Zen or Python comes into picture. This calling these methods, that is more practical, but it's not pure. Purest form is the C struct form. Okay. We already know that everything is a method call, so whether it's a len, addition, iteration, anything, any call that we make in which is calling contain, so any operation that we have in Python, it's all calling dunder method. So it means the Python syntax is just a sugar over all those dunder methods. Basically, we can do everything by calling those dunder methods, but these are just the wrappers. So all this, all these operators, in, for, if, all these things, these are all just sugar coat over the dunder methods basically. Another Zen, explicit is better than implicit. So implicitly it is calling dunder method, but what's explicit? The code that we are writing, in operation, for operation, plus operation, equal to operation, all those operations that we are doing. Okay. Now we have the basics clear. So we all know list is mutable, correct? We all know tuple is immutable. We all know set is mutable and unordered. What if we can have, a mix of everything? What if we can have an immutable list? Not tuple, an immutable list, just like frozen set. Can we have a frozen list? Can we have a set which is ordered? Can we have a set where we can do indexing? Can we have a dictionary where we can do slicing? So, sounds impossible, right? And we have never thought of it maybe, but it's possible. We can do it, we will do it, and I'll show it how to do it today. So, can we have list as a key in a dictionary? Why can't we have list as a key in dictionary? When we try to insert a list as a key in a dictionary, what error does it give? Come on, 3 years, 5 years, 10 years. What error do we get? Huh? Correct, but the error does not say it is mutable. Error says unhashable type. Correct? So it means there is something more beyond mutability and immutability, which is called hashability. And hashability is the core reason. Mutability and immutability is like a side effect. The actual reason is hashability. So all the hashable data types are immutable, because if you mutate it, the hash changes. Or if you change the value, the hash changes. That's why all hashable types are immutable. Now, what if I can make my list as hashable? Then I can add it as a key in a dictionary, or I can add it as an item in a set. Similarly, index in set, we know it's not possible. We cannot do indexing, but can we? Is it possible? If we can do that, think of the possibilities that we can have in our code. And mutating a tuple. Just now we said, right, tuple is immutable. Then how can we mutate it? And think if we can really mutate it, what powers it can give us. So let's see all these examples. Okay, but main reason why? So why should we do it? Why should we have a indexable set or a immutable list, or all those weird data types? The answer is simply because we can, and no one thinks about it. It's very easy, and we can. That's why we should do it. So we can do it so that we can rock. We can rock our code, we can rock our program. Okay? Another Zen, special cases aren't special enough to break the rules. So indexing a, let's say indexing a set is not very special, so I should not break the rule. But just immediately after this Zen, another line comes, which is, I've showed before also, practicality beats purity. So if it is more practical for me to have an indexable set, I can break the rule. So let's break some rules. And like I said, we can have endless possibilities: slicing, indexing, mutating, immutable, hashing, and all that. Anything that we want. So let's look at the code. Okay, so I have a list here, and I just implemented a hash function. Hash function actually expects to return an integer. So what I'm doing is I'm just creating a MD5 hash, and ORD basically gives me the ASCII value. So let's say if A is 64, so ORD will give me 64. And similarly, I'm just getting the integer value of every character of that MD5 hash and returning it as an integer, because it requires an integer. Hash function requires an integer to give out. Now my list is hashable because of this hash function. And because now it is hashable, I can put it as a key in a dictionary. And hash comes with another method called EQ, just like we have iter and next, or enter and exit, which go in pairs. Similarly, hash and EQ go in pairs. So EQ basically helps in resolving the hash collision. What if two lists will give me same hash? Then how will I resolve it? So EQ will do the hash collision resolution. And after implementing this hash function, you can see I have added it to the dictionary, and it works. You are seeing first time a list as a key in a dictionary. Has anyone seen it before? Good, bad? Okay. What if I mutate it? So let's say I will put fl.append, let's say some other number, 50. It still works, because every time it will calculate a new hash. Okay? Okay, moving on, next example. How much time do I have? Because I have a lot of examples. Okay. Fine. Set. So I said set is unordered, we know. So what we can do with set? We can make it ordered, we can make it sliceable, we can make it indexable. Because these three properties are not there, so let's add these three properties. To do slicing or indexing, we use square brackets, correct? And when we add or when we call a square bracket, it basically calls a getter method called as __ get item. So for both, for slicing and indexing, we will have to implement get item. Here I have implemented only get item for indexing. So I'm not doing much, just enumerating over the set. And as and when that index is equal to I matches with the enumerate value, returning that value. What's the disadvantage here? Every time at 0th index, let's say if I want to fetch, it will give a different value, because it is unordered. So every time at 0th index, I will not get the same value. But now it is indexable. Okay? So I have added, let's say, some fruits here, and I am doing indexing here, and let's run it. So now we can see we are getting the values based on the index, but every time this value will differ, like I said, because it's unordered. Okay? Let's move on. This is still indexing, not slicing. So if I do, let's say, let me uncomment this. Okay. So if I do slicing, then this will give me error because it is not yet implemented. Now let's implement it in the next function, in the next code. Okay. So this above part that you are seeing, it is exactly same like before. What we had here is exactly same. I added only this else part. So I'm just checking if is instance is of type integer. Basically, integer means it's an index value. So I'll return the item at that index. If it is a slice object, then I'll slice that set or whatever object I have and then return it. Slice again, it's an inbuilt data type or inbuilt object, you can say. I don't have to import it from anywhere. And simple logic, like basically trying to figure out the start point, the end point, and returning that many numbers. So if you are not understanding the logic, it's okay. The idea is we can do slicing, we can do indexing, and this logic we can define on our own criteria. On what criteria we want to index it, on what criteria we want to slice it, that we decide. And then we take that action. Okay? So now set are sliceable. Fine. So you can see it is slicing the values and it is returning. Okay, moving on. Another example where I can use this get item. So let's say usually when we give the value in the square bracket, we give the index value, some integer value. Now what if I have a time series data and instead of index value I want to give a date? So can I fetch the value based on date? Or can I fetch value based on date time? Just by putting that value in the square brackets. It's not necessary that you only have to pass integer. You can pass anything as long as we customize our method. So in this example, you see in the square brackets here, in the square brackets, I am not passing an integer. I am passing a date object. And date object is acting like an index. So index need not be an integer. That's the point. Okay. How it is working? Again, very simple. In the get item, because for square brackets I have to implement get item. And in the get item I have checked it is a date type. If it is of date type, I am adding that many number of days to, not adding, sorry, subtracting and returning it. So here I have this time series data, let's say starting from 1st January 2024, and I want to fetch the data on 10th January. Here I am printing at line number 30. So let me run it, and it works. So on that day, so here it is. On 10th day, it will be, the value is 21, whatever it is. Again, what it is returning, what the code is doing does not matter. What matters is we can have index not as integer but as any object. Can be date time, can be date, can be any object. Can be even another list or another tuple also. Okay, moving on. Data classes. How many of you have used data classes? Few guys, nice. So data class, again, very powerful. You can say kind of pure classes, mostly has only attributes there. We can define it. And here it says frozen is equal to true. It means it is immutable. So if I try to, let's say, run it, it says frozen instance error. It is frozen, it is immutable, I cannot change it. And this call p.x is equal to, so I have, it's a point object, x and y two coordinates are there. So p.x is equal to 10, this is giving me error. Behind the scene it is calling this setAttr method, which is, we know, right, every operation has a behind the scene dunder method. So both will give me same error. Now what I can do is, how can I mutate this if I want to? Like I said, everything is object, and for every object the meta class is object class. So I can use object class and then mutate it. Let me show. So here I am calling object, on that p object.setAttr, on that point object, and then changing the value. So now let me comment this and bring that code up. Okay. So the value is 1 and 2. After mutating, it should be 1 and 42 and 2. So let's run it. And we see 42. So it means even though it is a frozen data class, I can still mutate it with the help of object class, or object meta class. what do we learn from this? That immutability is not a guarantee, it's just a contract. We can anytime mutate anything that we want, even tuple, which is so-called immutable object. Let me show in the next example how can we mutate a tuple. Okay, so I have a tuple here, 1, 2, 3, and in the tuple, like everything is a pi object at the end, right? So tuple pi object has 4 attributes. It depends. In Python 3.14, the object has changed a little. In Python 3. Like before Python 3.14, this fourth flag attribute was not present. So what I'm doing is I'm going into that particular memory location where the tuple array is stored, and extracting that memory location and updating directly in the memory. I'm not using any tuple operations anywhere. Okay, so just fetching out the address, and at that particular index, I'm changing the value to 42. So my tuple, which is 1, 2, 3, will become 42, 1, 2, and 3. And the ID will remain changed. And we all know that ID gives the memory address, right? So tuple memory address will remain same, but its value will change, or the value will get mutated. So we see here, same memory address, values changed, tuple got mutated. Again, not a good thing to do, but we can. Okay, so important lesson. Anything which is immutable is not a guarantee, it's just a contract. And any smart developer can easily change it and corrupt the code also if they want to, if they are not getting paid enough. Okay. Generator, very basic concept in Python, right? I'm sure every one of you must have heard about generator. But how many of you know that generator can actually receive messages also? So usually we use generator to give values, right? But generator can receive values also. And actually generators are the basic, you can say fundamental backbone of the async coroutines. Or you can say generators are the purest form of async coroutines. Even the async IO that came in Python 3.6, if I'm not wrong, that also fundamentally, internally it uses generators only. Let's see how it works. So what we are having is, we are having a simple generator, and here a generator with a message. And you see before yield, I am doing equal to. Usually we just do yield something, but here whatever yield is not returning, but whatever message I am passing, the yield returns it, and if I can store it in a variable. And here I can use something called as send. So mostly we use next, because next method calls the yield, and yield gives the value out. But we can use send to actually send back the value back to the yield. And here that's what I'm doing. So I'm sending values, and this generator with message is actually receiving it. Now where we can use it? Okay, fine, where we can use it. So we can have a simple, very simple producer consumer with the help of generator. Or I can have my own coroutine if I want to with the help of generator. So here I have written a producer which will produce the values. Basically it will send the values. Then I have a scheduler, I have a consumer which will yield that value, and I have a scheduler which will just create this coroutines and call it. So I'm calling it coroutines, but you see it is all generator. And if I run it, the producer will produce message every 1 second, and the consumer will consume it. How it is going there? With the help of send call. And yield is picking it and giving it back. Purest form of coroutines without async. Now with this we can change our async behavior also if we want to. Going on to my last example. Okay. Another example of this where we can use send. So here I am calculating a rolling average in the form of a generator. So every time it will give one value, but it will calculate the rolling average without creating a list out of it. Okay. So when the value was 8, 0, it was 1. The average was 1. When the number got 2, the average became 1.5. So it's a rolling average. As the value is increasing, the average is also getting calculated on the fly. So these are some of the examples. So what did we learn? Immutability and mutability are side effect. The base thing is hashability. We have to look at hashability. And if we make something hashable, it automatically becomes kind of immutable. Second thing, all the render methods are the basic backbone. All the syntax that we have, plus, for, if, try, except, everything, with, everything, all these are just sugarcoat over the render methods. So I can write a pure Python program without any of the syntax just by render methods, but practicality beats purity. That will be pure Python, but it's not practical. Okay, everything is object, we know. Object behavior can be modified, and we know that every object ultimately comes from C struct. So yeah, true, it is an object, but only when it is in, we are talking about Python. But when we talk about C Python, it's C struct. Coroutines and generator we saw, and we saw multiple code demos. We also saw mutability is just a contract, not a guarantee. Okay, so Python gives us all these superpowers with the help of these render methods. We just have to think what we really want, and we can actually achieve it. Most people, we don't think about different use cases, but it's all achievable. So with great powers comes great responsibility. So use it wisely, because when we hack any data type, it is also prone to bugs, errors. We have to handle all of them. So we should know what we are actually doing. It's like a surgery. If you are not doing it properly, gone. That's all from my side. Thank you all. You have been a lovely audience. Thank you so much.